Hello everyone, let me introduce to you next a basic use of our partial discharge handheld detector. This is our main unit. There are several interfaces below the hose. This is the external synchronization cable, grounding, and our headphone jack. Sensor and the charging port. This is our switch. This front part is built-in. A sensor module in our tape booth. This is a module of an air ultrasound. This is an interface we leave for future expansion, a reserve interface, which may be expanded in the future. Some other related functions. Okay, let's turn on the power and boot up. We can see here. This is an air sensor, which is an ultrasonic sensor, and then we are in front of this side. You can see it here. Okay, let's rub our hands in front of it. There's a sound. It can record one of its. A test value of a simulation. Because in our normal cabinet, we mainly use the gap of the cabinet. If there is discharge in the gap, we can check it bit by bit. If you had that, environmental background noise, like what? My environmental noise, for example, it's always 19 or 22. We click on Settings. It takes that current discharge level as a baseline. And then conduct an inspection. Because this is the background noise, we need to subtract the background noise from the measured noise, and then we get the noise of the discharge capacity. Then there's our click switch. It has a tape built-in. Okay, here is the tape built-in. TEV built, in words. Its sensor is relatively sensitive. It's here. For example, if there is a cabinet here, we need to stick it on the cabinet, and stick it here. And you can see its discharge capacity. This is the usage. Then, the next one is our ultra-high frequency. The ultra-high frequency sensor is connected to us. There is a sensor interface here. Insert it. Align it with the groove. After plugging it in, it will automatically switch to UHF. This is a basin type that measures our ultra-high frequency, which measures the UHF. This is used to test our main test items. It measures the internal discharge of a pod insulator. The internal discharge. Just hold the handle and stick it on. You can stick it on the basin insulator, because it has a knock. Then this high-frequency current sensor is our HFCT sensor. After we plug it in, our instrument will automatically identify it. For example, if we turn on the sensor now, this sensor, mainly used for testing a cable, which has a ground wire. We clip it on the ground wire. It is usually clipped on the ground wire, and then detect its partial discharge. If we measure the main transformer, it also has that ground wire on it. But it needs to be compared with the environmental value. It cannot be said that, for example, this wire. It acts as a grounding wire. After we clip it, I want to measure the device after grounding. If there is a discharge, okay, after I clamp it, I will test it again to see how many PC it is. After testing, for example, I see it's 2.8 PC. Okay, I'll clip it to another wire. If it's also 2.8 PC, it has an environmental value. We need to take the environmental value, and then use it as a reference, as a reference. Okay. This is the basic usage of the instrument now. It's introduced.